Hi, everyone. Welcome to the second round of Q&A for day one at Video at Scale. I have Murali from Idiom Systems and Denise from Meta with us to answer the questions that you guys have for their talks. Thank you for your talks. I think it was really cool learning about how video playback works for videos at scale. I think we have a bunch of really good questions, so I'm just going to jump right into them. The first question is for Denise, and the question goes, are the quality and bit rate limits achieved using KEP CRF encoding, or do you employ some content adaptive encoding?
Hey, well, thanks for the great question. So first caveat, so my expertise is more on the playback side, but work really closely with our partners on our encoding and processing teams. So especially for our more advanced encoding families, like for VP9 or AV1, we actually rely on a lot of pre-processing and optimizations to build out like an optimized convex hull. So what this pre-processing does is at different encoding settings, different resolutions, we'll kind of be able to assemble that final convex hull, and then the output would be a CRF we would end up using for each encoding in the ladder. But it is very content dependent, and we don't have like a fixed bit rate or a fixed CRF that every single encoding lane in the AVR ladder would get ahead of time.
Got it. Cool. The next question is also for you. So why only 3 subjective buckets? Why not, for example, standard 5 buckets, having excellent, good, fair, poor, bad? Or is there any specific production or practical values to having 3 buckets?
So I think the important nuance here is really kind of the differentiation and the distinction between MOS and acceptance annoyance. So what the acceptance annoyance 3-bucket model is really giving you is, in a specific context, is this MOS scale viewed at, or is a specific MOS score or quality score acceptable or not? And the thesis is that in different contexts, for example, a MOS score of 2 may be unacceptable, or it maybe it's a MOS score of 3. So as an example, this isn't really relevant to Meta per se, but there has been prior research in the space that shows the amount that you pay for a streaming service may impact your expectations around what quality is good enough. So the more you pay for a service, the higher your expectations would be about quality. And more in our case, for example, I think you talked about kind of your data budget might be a factor if you're watching on Wi-Fi or cell. If your battery is about to run out, if you're low battery, you might be more acceptable or more accepting of a low MOS score. So it's really trying to overlay this acceptance annoyance scale on top of MOS rather than only looking at MOS and trying to understand which factors are most salient in making that decision.
So does the buckets shift based on like what app the video is being played in?
I think there's a lot that we're still learning in the space. So we're trying to understand what are the factors that might come into play, and how do we actually apply those in context to make the right decisions for our users.
Got it. Thank you. Murali, the next question is for you. How are the test cases and test points decided? Do we need to provide them, or can Idiom design those?
Yeah, it really depends. For example, if the customer, or let's say in this case, Meta has very clear requirements, then we can take the test cases that are coming from the customer. If they have a very high level requirement and they say, okay, you go and decide what kind of bit rates have to be tested with, or what kind of features have to be tested with, then we can jump in and design the test cases. So it really depends on what the customer really wants. If they're very clear and they have their own test cases, then we could use them. Otherwise, we can define and design the test cases.
Got it. Yeah, flexibility is great. The next question for Denise. How do you address the conflict when the quality scores are the same for 2 different resolutions, but at the same ABR rung or representation? Do we serve the lower resolution or the higher one?
This is a good question. I want to make sure hopefully I get the intent of this question correct. If not, let me know in the comments and I'll try to follow up. So generally the expectation is if the pre-processing convex hull model I described in the first question is working, we generally wouldn't expect the player to be provided with an ABR ladder that has multiple choices at the same quality. Like we strive to have kind of good, just noticeable difference spacing between the lanes that we can choose. It's possible that if scaled down to perhaps a very small viewport, maybe the quality will saturate and there may not be quality gains from continuing to go up within that specific viewport. So if we did end up in a scenario where there were no meaningful quality gain from playing kind of a higher bitrate encoding to the user, we would default to using basically the quality lane at the lower bitrate that has the same quality score.
Got it. Awesome. The next question is from Murali. Was BD rate used to measure the compression gain? And if so, what quality metric was used for benchmarking?
Okay. So yes, typically BD rate would be the, I would say, a top pick for measuring the compression gains. Right? But of course, we can also do some visual tests, and like what Dennis also mentioned, you can use just noticeable distortions and things like that. But yeah, BD rate would be a very top pick for objective metric that you can start with.
Got it. Awesome. The next question is also for you. So do we need to test for capabilities of different devices with the same chipset?
Yeah. So what we have found from our experience so far is that even though the chipsets are all the same, the OEMs, for different reasons, maybe they want to have a lower skew for at a lower cost, so they really actually turn off some of the features. So even though the chipset is the same, the OEMs can switch off some of the features. So then you would not get those features available on those SKUs. So it is very important to do different tests, even though the chipsets are the same.
I see. So that's why you have so many different devices.
Yeah.
All right. The next question is for Denise. How does ABR handle live videos where the bitrate and quality values of different lanes may not be available a priori?
It's another great question. So live comes with a whole host of unique and interesting challenges on top of video on demand, which is tricky enough to get right in some cases. So specifically around the quality and bit rates that could change, we don't necessarily always have the same real-time quality scores to make the right decisions. We do attempt to send the client kind of like a running average current bitrate for each of the ladders to make best guess decisions around kind of when to adjust up or down as needed based on the current network conditions and current buffer status. But it is it does come with its own challenges.
Got it. Makes sense. The next question is also for you. So how important are frequent quality switches in determining user experience? More concretely, do you see user engagement reduce when the quality fluctuates?
Yeah, there's a lot of factors that really go into the quality of experience. And it's, I think, a challenging area of research to really pin down how much any one factor matters. Like even with the quality, do you do the watch time weighted average across the entire video? Do you have some sort of like recency weighted bias where you look at the quality at the beginning of the video is the most important, or maybe it's the quality at the end that's the most salient? So I would say that this is far from a solved problem and definitely goes into this bucket of lots of opportunity for future work and future understanding. I would say that one thing we do monitor at least is tracking over time what the the frequency of quality switching is in production. We've definitely seen that be a signal before, where if it makes a sharp jump up or down, we need to at least take a closer look and make sure that we don't have some kind of unexpected bug in production, or understand like kind of what the cause of that is, because it could be indicative of a problem. I mean, I think all things being equal, like you definitely don't want it to oscillate back and forth. Like say that you had a choice between just using resolution to keep things easy, say like 360p, 720p, 1080p. Like if you could just kept jumping back and forth between 360p and 1080p every 5 seconds versus staying at 720, like that would probably be annoying. So I think you definitely want to make sure that you don't have bugs there. But I think in terms of how exactly you model that into the quality score, gets a little bit more complicated.
Got it. So is there active work at Meta right now to actually maybe figure that out more?
It's, I think, one of the areas and like one of these factors of what are the things that matter. I mean, there's also like how much does audio quality matter? We know that that's very salient to the overall quality of experience, but how do you weight the visual quality versus the audio quality? Does it matter for different content differently? I think there's a number of there's lots of room to kind of continue to improve this model and make it more holistic.
Makes sense. Thank you. The next question, I think, is from Murali, but Denise, feel free to chime in if you have anything to say. The question is, how is the per core utilization measured on the device while encoding, decoding, and processing?
Okay, yeah, I'll answer that. So the per core utilization is done based on how many threads you're running your particular software under test. You could be running them as a single core, or you could be running them as a 4-core or a 2-core. So based on how many cores or how many threads you are spawning, you can look at the per core utilization.
Got it. Thank you. The next question from Murali. Do you think there are other factors, maybe like temperature, that can affect phone performance? And how do we account for these in the experiments?
Okay, so all of our experiments are done under the normal room condition, because that's how the video is going to be consumed, most likely, right? Mm-hmm. So most of our tests are done under the normal room conditions, temperatures. The only thing that we feel could affect the performance in terms of temperature is how much of clock speed the processor is able to sustain. That's the only thing I can think of. But typically, all our tests so far have been done under room conditions.
Got it. Thank you. The next question is for Denise. So I think you mentioned about non-reference original quality as like future steps or things that Meta is investing into right now. What are the additional challenges for understanding this?
It's a lot less of a solved problem in terms of what's the best way to really handle this content, to just take an input stream and kind of reduce it to a value of how good that quality is. I think there's a lot of interesting challenges also in kind of some of the new formats that we're seeing are really popular in short form video, where you really have like multiple layers of content. So for an example, you may have an original source video from a camera roll that was captured at 1080p and a high bit rate that looks very sharp. And then you have like a dancing Bill Hader sticker on top of it. That's intentionally like a little bit lower res. And like, how do you define what the composite score of that content is? Or the inverse, where you may have like a throwback clip from like a 90s commercial with then very sharp overlaid text on top of it. Again, how do you judge what that final quality is and kind of take it into account for what we present to the end user? So it's definitely something that we are interested in understanding more, and doing some work here and trying to understand which features are most salient and most aligned with like user perception. But again, it's has a lot of interesting challenges, especially at scale of doing like the number of uploads a day that we handle.
Awesome. Thank you. The next question is also for you. is there any work done to dynamically generate new bitrate or quality levels to give the best user experience?
That's a good question. So one thing that we do is not necessarily dynamically create new lanes on demand, but we do have a mechanism that, say, a video goes viral at some point after it's uploaded, where maybe based on the initial watch time predictions, it didn't seem like it may qualify for something like our AV1 encoding recipe. Because we want to strike the right balance of making sure that we use our most like compute intensive codecs for the content that will get the most distribution. We do have a mechanism for like after the fact, if we detect that, oh, we didn't think this was going to get a lot of watch time, but actually it is really popular. We can then basically enqueue it for our more advanced encoding families. So something that does have a kind of marked shift in consumption patterns will get new encoding lanes in that way. But it's less of a case of, oh, we see that we only had a 360p lane and a 720p lane, and now we're going to like go and insert a 540p lane in the middle. Or we're going to go and put like a 144p lane at the bottom.
Got it. Yeah, maybe like helping viral videos go more viral by sending better quality encodings. The next question is for Murali. What are the other areas apart from media where such end user device capabilities can be useful?
Yeah, so we now see that most of the devices, especially the mobile phones, are coming with AI-enabled features, right? So it will be good to study what these AI features can be used for in terms of video capabilities, whether it is encoding or decoding. So studying the AI-enabled features may be a good task to consider in the future.
Got it. Thank you. We have another question for Denise. So are there other factors worth considering when making playback choices? I guess this ties in line with what Murali was talking about, battery life, device temperature, maybe CPU consumption. Do we consider those as well?
Yeah, I mean, I think there's considerations that are made first in terms of like which codec is most appropriate to decode on this device and what the device capabilities are, if they can even decode certain content in the first place, and if so, at which resolutions, when trying to decide, well, do you allow perhaps like a lower resolution BP9 or a higher resolution H.264 stream that might not be like compressed as well. I think there are other factors that we're also continuing to understand. So then you might have the question of, okay, it's capable. It's not a question of just capability. Like it can decode, but which one is optimal? And there are some things to consider in terms of, I think, battery life and kind of client-side compute costs when you're evaluating, especially like hardware decoders versus software decoders and different options. So that's something that is being looked at.
Awesome. Thank you. I think we have time for maybe one more question. And the last question goes to Denise. So what are the challenges that you face when you try to launch a new quality metric?
Yeah, so you have an idea for a quality metric that is more accurate, but one of the challenges that you have is once you're actually relying on these metrics to make client-side decisions, it's not always as simple as we've done some research to prove that this one has higher predictive accuracy, ship it and move on. You definitely have to run production tests because it may impact the ecosystem in a way that you don't necessarily fully predict. So you want to be able to quantify that and measure that. This is especially challenging when you have metrics and when you have new metrics that might not be on the same exact scale as the old metrics, and you have different kind of numeric thresholds for making certain decisions. So it can be a more involved effort to make sure that we do this in a coordinated way across encoding and playback and delivery, and also monitor this real time to make sure that it has the desired kind of positive quality of experience on the end user that we expect.
Got it. Makes sense. Thank you. I think that's all the time we have for our Q&A. I want to thank Murali and Denise again for taking the time to teach us about things they're working on and answering our questions. So I want to wrap things up. I think we have one more closing remarks by Shinjin, but after that, I think that marks the end of day one of Videos at Scale. Thank you, everyone.